All right, well, welcome. Can you guys hear me okay? All right, my name is Rick Hill, and I'm here today to talk about geolocation of wireless access points and a little game I invented called wireless geocaching. A little bit about myself. I work for a company called Tenacity Solutions in Reston, Virginia. We do security consulting mainly for government customers. And around there, I'm known as the wireless SME, which is a subject matter expert, local geek, car mechanic, and manager most likely to be thrown from the bus. Keeping the management thing in mind, I'd simply like you to focus on the technical, my technical skills during this presentation. I always like to keep an open mind, so anybody out there, I have contact info for you if any for jobs or whatever, so, or future contracts. Last year, I presented war rocketing, which was somewhat unusual. This year, we're changing things up a bit. Things are a little more laid back this year, I guess you can tell. In keeping with my penchant for discovering new and better wardriving techniques, we have a new venue, it's the lake, and a new vehicle for DEFCON 15. It's called the Warboat. Boat weighs 4,800 pounds, carries a crew of 10, and small quantities of beer are allowed. If you behave, you're not likely to be stopped by the cops, which is more than can be said for regular wardriving. Unfortunately, I couldn't bring this as a prop this year. Agent X wouldn't let me bring it in the exhibit hall, so instead we have the actual unit that we did the radar antenna that you see here, what we use for our war boating. So the focus this year is a little different from last. Last time I just shot up the rocket and tried to, basic net stumbling, let's see what's out there within 20 square miles. This year, it's all about precise location. The military affectionately calls what we're doing here targeting. However, I'd like to focus on the positive side. Geolocation, as you know, can be used for many other things, good and bad. Things such as, I'm sure you're aware of OnStar. Lost kid location is another that I saw, and I'll talk about a little bit further in my talk. And down skier rescue and so on. And looking at a little background on geolocation, I'm an amateur radio guy. And of course, I do some of this on that side, but people at the Naval Research Lab and others have documented at least 4 techniques for geolocation. As you guys know, Netstumbler doesn't geolocate, simply gives the driver's GPS position. And I started thinking about this, and I was like, I go around mapping access points all the time, but I really want to know where they are. I have a friend that's into geocaching, if you guys are familiar with that. And, of course, he locates his cache treasures all the time with his GPS. It's a little harder in the Wi-Fi world than just simply getting a GPS coordinate. But I started thinking, and I said, well, what if we combine the two? We can have a new sport. Let's call it wireless geocaching. Today there are well over 350,000 geocaches out there in 222 countries, and they're registered on the various websites devoted to the sport. At each one of these, when you basically get a treasure when you find the proper GPS location. Some of them are actually quite difficult. You can find the location, and your treasure may be hidden on a cliff near the location, so it can be challenging. Before we talk about the project goals today, let me just say I'm definitely more of a hardware engineer than software type. I'm not really a programming guru, so keep that in mind when you look at my basic code for this thing. A lot of the talk is about the design and construction of the unit you see up here, and at the end, hopefully, we'll do a short demo. We actually have one of the goons hide an access point in a room here. We're gonna see if we can nail it. Next. All right, the 4 Direction finding methods we'll go into a lot of detail about later. Of course, our platform, you've just seen the picture, Sea Ray boat. The equipment, pretty much a 15 dB antenna, something called a stepping motor, and Netstumbler, VB, and Windows XP. Next. So what are we going to talk about today? Why is wireless tracking and geolocation so hard? And the advantages of the 4 techniques. What I did when I first built this unit was I did a static test on land because I didn't want to put the sucker on a boat and go out in the waves and try to figure out what was going on with it. So we do that first. We do a number of known APs on the lake where we hide them, know where they're at, and then finally we play the wireless geocaching game. We've got some video of that. So why is it so hard? Geocaching is difficult because, geolocation is difficult in the Wi-Fi region because it's spread spectrum for one thing. You can't just lock onto a signal. If you're an amateur radio guy, you're typically picking up narrowband, one frequency transmission, and that's fairly easy to do. Also, we must wait on the beacon and probe frames, and of course, you guys probably know about the multipath and trying to, it's problematic to try to find access points in trees and large buildings and stuff. Therein, the lake location that we pick. The 4 techniques are radio direction finding, which means basically, let's just point the antenna, see where it goes. Right? So, boom. That's sort of a crude manual technique. The next one is receive signal strength indication plus angle of arrival plus triangulation. That means that I picked a couple, any 2 or more spots, and in our case we have an automated system that's going to pick out the max signal strength. Well, back from your geometry, if you get any 2 out of 3, any 3 points out of a triangle, then you can calculate all the other points. The third is Doppler direction finding. Most of you guys are familiar with police radar and some of the other equipment that the federal government uses. The last one is time of arrival and time difference of time of arrival and time difference of arrival. We'll go into these next. Radio direction finding, again, it's low cost. All you got to have is an antenna. Everybody with a antenna has done this. It's not rocket science. Here's the triangulation for those of you that don't remember your geometry. It's the law of science. I'm not going to go through a lot of the math that we did this, but I have some Google Earth pictures of what we captured as far as we could actually capture the error because when we planted the treasure or the access point, we recorded GPS position, and what we would do is once we found it, we'd do the error between where we found it, GPS position, and where it really was. So we've got a good idea of, we're going to get a good idea at the end of how accurate we were. Doppler direction finding. Basically the reason I didn't do it, I would have liked to have done it, but it's very expensive. You can build equipment for about $3,000 in the 2.4 gigahertz region. It is better for moving targets. The bad part about the rig you see right here is it pretty much has to be stationary. It takes about anywhere from a minute to 3 minutes to do a scan. So it's fine for using on your car top or where you park, but you're not gonna go flying down the interstate and do triangulation or location with this thing. It just doesn't work like that. It's pretty much a stationary unit, which is the reason we didn't go with Doppler. Time of arrival, time difference of arrival. You guys have probably seen this on the TV shows, CSI, whatever, about the cellular tower signal location. That's one way it's done. The other way it's done is there's a company I found called aeroscot.com. What they do is kid tracking, and it's either Busch Gardens or it's one of the big amusement parks wherein they give your kid it's actually a little Wi-Fi transmitter, and they've got receivers planted at various areas of the park. It's a great thing. It seems to be working out well. So you guys check that out on aeroscout.com. The disadvantages of this time difference, it's electronically calculated time difference of arrival, is it's not as accurate as the antenna method. So I want to focus a little bit on how I constructed this thing. I got some pictures here for you guys. It basically consists of a stepper motor to do the 360 rotation, motor controller. I opted not to use the laser pointer. It didn't work out well on the lake. I really didn't want to try any more night raids. The miniature antenna, and of course this little stand here has been adapted for my boat. It's just upside down. So basically this whole thing came in about 150 bucks. So here you see the hardware. As a guy, of course, I subscribe to the theory that bigger is better. Unfortunately, the antenna you see here at the top, the big one that I first bought, just wouldn't cut it. The stepping motor would not crank it around. If you can see the unit right here, stepping motor is probably, I don't know, maybe a dollar size. It's not real huge. It really impacts the cost of your project. You buy a big stepper motor, it's going to cost you a lot of bucks, particularly for the driver and the motor. So that particular antenna there that I decided, the one you see on the lower part there, is 2.9 ounces, so it's ideal. It's 15 dB. Next. Of course, if you build your tracker, you've got to have some kind of surface to put it on. In my case, it was a table. You could put it on. You could easily put it on a car top or one of these camper carrier kind of things if you wanted, because those are transparent to microwaves. They work really well. You don't want to leave it flapping out in the wind. But what you see on the slide here is that's basically a Lexan piece I use and cut out for the top, and there's the little stepper motor that I bought beside it. It's a DigiKey motor. I think the stepper motor cost me $17.95, and you can also get these out. Interesting enough is if you've got a copier or disk drive, you can get them out of old copiers and disk drives. So you can easily trash an old computer and get your own stepping motor if you don't want to pay for one. Next. Second step in building the tracker, you got to mount the antenna. This is a very difficult step because, sorry, I didn't mean to zap you guys. If you can see the detail in the lower right there is actually all you got to work with is about a 1/4 inch shaft there. So what I did, I welded a little mounting piece onto it, put a couple of set screws in it, and actually the set screws clamp down real well on the shaft of the stepping motor. If you go into buying gears and all this stuff, you're not going to have a very successful project because it's going to get real expensive fast. So that's simple and easy. Next. To run the stepper motor, if you're electronically inclined, you can build your own driver board. I didn't have time to do that. I fired this thing. Fire is a bad word in electronics, but I first started building this thing about 2 months ago, and I ordered this board. It's called the Gadget Master, believe it or not. So you can, if you want to Google that, you can buy it. They're not very, and the driver's probably about 150 bucks, which is about 50 bucks more than you pay for the electronics. But I just went with it because it comes with the VB code to run it, and it's easy to interface and to run stepping motors of the size we need. Final thing before you launch into Visual Basic, Visual C, or whatever you want to program this thing in, is testing it. The guy also sends out a nice stepper program that you can use for all kinds of robotics, and it'll test out your motor. And so basically what you see here is the first test of the motor that we did. The final step for the tracker, I really needed not just the stepper motor controller, which you see here, but I needed a compass to get the fixes on. You can't do triangulation if you don't know where you are or what your angles are. It becomes very problematic to measure angles, particularly on the water. I found a nice little digital compass and mounted it on the back of this thing right here. And as soon as the software locks onto the signal, you just take a digital compass reading, and it gives it to down to 1 degree accuracy. As I mentioned, I skipped the laser pointer because it really didn't work out for me. So here's what it looks like on the back of my warboat. As you can see, the table stand, and that's looking out back of the boat at sunset, and worked out pretty well as far as the mounting position. Next. So there are a lot of ways of doing this as far as motors, if any of you guys have ever played with motors. Stepper motors achieve very precise control, and the cool thing about them is, like, I know you guys have probably seen the radio-controlled helicopters and stuff like that. They use a motor called the servo, which really, it needs a feedback loop in order to operate. The beauty of a stepping motor is it'll go to the same position regardless. You tell it to go to 250 degrees, it goes to 250 degrees repeatedly. So greatly simplifies the construction of your electronics. You don't need any feedback or a lot of other circuitry. As I mentioned before, old floppy drives are fine for this. Just a little background on stepper motors. They really don't rotate the way regular motors do. They have teeth, and they rotate one tooth at a time, and they're very sturdy. You can hold on to the shaft of one, and it'll just, if you power it up, it's there. I mean, it'll basically just about rip the motor out of your hand. They're high torque, and they're really easy to operate in terms of discrete degrees. A little bit about the antenna selection. Do I have anybody that's into radio direction finding in here? Any amateur radio guys? Sorry, can't see. Okay, it looks like we've got a couple, so you guys can probably comment at the end. But the antenna selection is very important because you have to get an antenna that's got a narrow enough beam width in order to zoom in and get an accurate compass fix. So this particular one, you can see the pattern. That's basically the pattern this way and this way. They're pretty much the same. This particular antenna has about a 30-degree pattern, and it worked out real well for us as far as zooming in on the target. A little bit about the other stuff that I used. I used a Cieno PCMCIA card with a Prism chipset on it. It gives it's a pretty strong card. I think it's like a 200 milliwatt card. The front end monitoring on this thing we used was Netstumbler. But what I did is just get the signal from the Netstumbler and output it to a file. There's a little scripting utility, and that's how we got our front end signal. The screen you see there below, you do have to have a target access point. So either for the game or for geocaching or for the location, we first roved around in the boat and found out possible targets that we wanted to find to locate. Then you enter it in the program and go about your geolocation. As I said before, use Visual Basic. Visual Basic code picks the max signal strength up out of a file, gets a bunch for each movement of the stepper motor, and then averages. I think we're doing like five signals per 3.5 degrees or something like that. It's 100. This particular motor is 100 steps per revolution. Here's the programming sequence. The boat cruises. First we went out into the lake and we looked for a target access point, whatever that was. That was either one my friends had planted that I knew where were, or ones that they had deliberately hidden from me that we went out and did our geocaching game with. The VB, I had it programmed to come up big red letters, target acquired, when I found, I got to that area of the lake. So the area we used was about 5 miles on either side of a marina that I put in at Lake Anna, Virginia. And it was fairly easy. I mean, we had a 9 dB set up, and we were pretty much all over top of the targets in about 10 minutes anytime we left the marina. So This is real easy to do on a lake. It's not like driving around your neighborhood trying to avoid cars and trees and all that crap. Works real well. Number 3, we switched to the directional antenna, which is the scanner here, and that's really the sequence that we use for the scans. Save GPS coordinates at that particular spot, record the reading and angle, and from those readings we can calculate exactly where the target was. All right, so what we did is, I call them sorties. We took a couple days off from work, and me and my friends went down to the lake, and we ran 8 sorties over 2 days on the boat. The first one, as I said, was, the first one actually was a static test on land near my house. So I'll show that to you. I've got some Google Earth shots that look pretty cool. And then we did 4 against APs with known GPS positions just to get a feel for how the equipment worked. And finally, we ran a couple geocaching games. After I did the geocaching, I decided to go after targets that I didn't know where they were, and I didn't have visual line of sight to them. I couldn't see them. And here's the results. The static test with a land-based AP, if you look, this is fix number 1. Up top here, this is fix number 2. The actual calculated looks like it's in the building there, so we were off on this. I've got the numbers, but I think it was like 50 feet or something. It's really not bad because those fixes were taken about 1 kilometer out, so those are about 1/3 of the mile out. So it worked out pretty good for starters, and we decided to go ahead and try it out on the lake. Next, we turn our attention to Lake Anna. I don't know if you guys know wiggle.net, but it's a mapping site where people go around and do wardriving and log their stuff. If you'll notice real close and looking at this map, apparently nobody's ever done this from a boat or owns a boat that does wardriving. I mean, it should become pretty obvious to you that Netstumbler is giving you the driver's position, so we thought we'd improve that a little bit. Next. This is a test on the lake. We went to a little place on the lake called the Islands. Up to the right here, you see the Visual Basic program, and it's doing the scan. It's already done the scan actually. And what I'd like you to look at is here. 360 degrees starts about here and ends about here. You can see you got a clear bell curve. It looks just like that antenna pattern. Well, guess what? That point right on the top there is the exact compass reading to your target. Furthermore, what the program does for you, if you want to use this just for, it's pretty cool to throw up on your roof, you can actually use this to zoom in on pretty much any Wi-Fi signal and lock in on max signal strength. So it's doing a pretty repeatable job of tracking and locking in on targets here. The math is far from easy. I won't dwell on this, but if you want to do triangulation, how cool your GPS is. It just goes, hey, you're at spot A, hey, you're at spot B. Well, that's the luxury that geocachers have when they use a GPS. They can simply use their software. We did it the old-fashioned way. These programs, you see, there are a couple that give you your distance between 2 points, and also the forward was very important. Forward program from the National Geodetic Survey was very useful for giving the final distance and angle to my targets. I was originally going to incorporate this in my VB programming. It became very complex. This stuff is like 20 pages of Fortran that's like 30 years old, but it works really well. So we just use standalone programs, these two off the website, for calculating our targets. Second sortie was done at Anna Point Marina, and if you see right here, this is where we put the boat in at, and fix number 1, fix number 2. I had a real problem when I first started out. This is my first try on the lake. And one of the things you got to consider if you do this on the lake is you either got to be on a beach spot or you've got to throw out a couple anchors, because obviously when you're sitting there like this, you don't want your boat rocking around or moving angularly. So unfortunately, fortunately I threw out 2 anchors and I got some really good readings here. We pretty much nailed this AP. However, I'm only used to using 1 anchor, so when I took off after I'd done this fix, I left the other anchor in the water. I was cruising about 30 miles an hour and heard this big noise, turned around, and I'm like, WTF, there's this rope hanging out the back of, I'm like, what's that rope go to? And just about then, it was actually the front anchor that wrapped around the rear anchor rope. The anchor come flying up on my swim deck on the back of the boat. Thank God it didn't put anything but a small hole in the back of the boat. So if you guys do this, I caution you, please be very careful boating. It can be dangerous. All right, so that's basically a couple of the initial searches. What I like to do now is show you guys a little video of what we did as far as our geocaching game. This is where we had 2 teams of 2 people. First team drops off the bucket containing the AP and the geocache treasure on a shore. The rules we set for the game are that we had to be within 5 miles of that marina that I just showed you and 100 foot of shoreline. Otherwise, anything was fair game. So my buddy Mike, who you'll see on the video here, had fun with me on this. And the second team, of course, after it's hidden, we go out and find it. So go ahead, Reese. Hang on. Sorry guys, I just want to get you the audio now, so it'll really suck if I play it without any audio. Wow. She's my mate on the finder team here. So we're ready to start the expedition. They're getting ready to leave the dock right now. And we'll catch them in about 20 minutes, and we're going to find out where they hit all the butte. So we've disqualified Captain Mike from driving since he was part of the plant team. And now it's Captain Kathy. I'm here. Here's what we're going to do. We're going to go that way first. And down towards like the red boat. Try to stay in the middle of that channel though, because it's really shallow to the right there. So we've got the target now, guys. It is here. We're in the islands. We're not exactly sure where it is, but we're in the general neighborhood. So as you can see, if you want to pan around, like there's like 5 or 6 little islands here. Yeah, sorry about the wind. What I'm saying is we had found the target. Yeah, finally at the island. Go ahead and put the nose up on the beach here. I'll tell you how to do it. Just keep going. You want me to do it? I'm just going to park here to do my scan. All right, so we got our first position, and now we're going to go. We're going to get the fix number 2, and we're going to see where it's at. It looks like it's either on the point of that island or the one over there. I can't quite tell, but the numbers should figure that out for us. So we're going to go on to spot number 2 here. Oh yeah, that's a rocket signal from down there. We definitely need to do the scan here.
Location for
I just want a location. I mean, you should be able to put it anywhere, right? We should be able to find it, so. Booty right on this point right here. I'm losing air rings, Kathy. Here's the booty. Woo-hoo! We did it! Thanks. Yep. Next one. All right, so actually this is a scan of that Silver Fox, which is actually the access point that one of the goons hit earlier in the room here. So it worked out real well. That beach, the beach that you saw, pretty much when I closed in on that, I could tell where they landed on the beach, and it wasn't too difficult. He hit it back in the trees about 20 feet, so didn't have to do too much searching on that. The interesting thing about geolocation is it works real well at about up to several miles out. You get in the neighborhood, so to speak. Once you get closer and closer, you can get really good at this. I mean, this antenna will nail it down to like 10, 20, 30 feet once you close in on your target. So the closer you get, the better you are. And in fact, you almost don't need quite frankly, the automated scanner. Once you get really good at this and get close, you can just go, yeah, that's it right there, and just nail it. So this is a signal, again, the bell curve right in the middle, and that was the beach point right there. We did encounter a couple challenges with finding this in one of the other games. In particular, this is a digital globe image here, looking at the GPS positions. The first one there you have on your left was a scan I did, and swore that the access point was on the beach right here. Well, guess what? Got up there, got out of the boat, and my signal disappeared as soon as I walked onto the beach, and I'm like, what's going on? Well, I believe that one of my assistant Diana said, well, I think some trees are probably blocking your path here. And so, yeah, there were a lot of trees. It consisted of that point right there. Anyway, once we got back out in the lake, got around the point, we actually had to do 3 scans on this. We pretty much nailed the beach right there. But it's problematic, and these kind of problems are readily apparent on land because trees just suck for Wi-Fi. I mean, you can't get through the foliage. So, this picture is actually finding an access point in an unknown location. I just picked up an SSID of default when I was cruising around up here. So we decided to go after this one. The yellow line shows the fix to target, which is on this point here, actually on the other side of it, well, on this side of it. And that was approximately 1.2 kilometers away. So we'll show you how we zoomed in on that. After 2 fixes, it became apparent was on this point, so we got in closer. There are 3 possible houses it could have been, and keep in mind we were, about half a mile out, or about 1.2 clicks out. There's a house like right here, there's one here, and there's one here. So pretty much our first scan got us in the neighborhood, and let me show you what we came up with. That's the house right there. As soon as we closed in on it, we just zoomed right in on that location. And we couldn't see this when we originally started scanning. So pretty cool that you can Google Earth with the GPS position, having geolocated a house. I mean, you can basically come right down on their roof and find out where your target is. All right, this is pretty much a summary of all the tests we did at Lake Anna and the land test. At an average distance of like well, 3/4 kilometer, the error is pretty great. It's about 100 meters, which is about 100 yards. That's not good, but it is good when you consider that your compass is like plus or minus 3 degrees. Plus, you're sitting on water, you got waves. For every degree at that distance, you're about 100 feet off for every degree error. And you can figure how small a degree is. Okay, that's 360 stopping points on your program right there. We actually didn't go to that resolution. We did plus or minus 3 degrees. We did 100 points in our scan. So plus or minus 3 degrees, that's about as good a resolution as you're going to get with a mechanical system. So what I want, when I first started this thing, I wanted to see how accurate is this compared to geocaching. Obviously, it's pretty pathetic compared to GPS. However, if you really want to find somebody, you can do it with triangulation. There's no question about it. I mean, law enforcement does it all the time. The FCC does it all the time. It's not hard to do. And, of course, much better than Netstumbler. I haven't had a chance to post on Wiggle, but I'm going to post my targets that I picked up on wiggle.net before I get back next week, and we'll have those out there. So that's pretty much how good the technique is. You can make it a little better, but it probably costs you a lot more money. Again, the geocaching game was almost under ideal conditions. We had a clear line of sight, no traffic other than 1 or 2 boats, and virtually no interference other than a couple islands we encountered that gave us a hard time. Clearly in a city or urban environment wouldn't cut it. As I mentioned before, sorry, go ahead, one more. The amateur radio guys will tell you this, is radio direction finding is really more of an art than a science. And historically, it was one of the things that was largely responsible for the defeat of the German U-boats during World War II. If you go out into Google, in fact, I think there's a display on RDF at the Chicago Museum. It's called Huff Duff, which stands for High Frequency Direction Finding. The other thing to note is that it's very dependent on the triangulation on how big your triangles are. If you get a big flat acute triangle, which means you've got all your angles under 90 degrees, it's sort of your standard triangle like this, then that's going to work real well for you. If you get a flat triangle, well, guess what? I mean, if you've got a real flattened out long triangle, your error, every 1 degree error is going to account for a lot of error in finding your target. So pretty much that stuff's just up to chance. With experience, you can get really good at this. Like I said, we had a lot of fun not doing the calculations and just, quite frankly, finding targets once we got the equipment going. I'd recommend you first find it, if you can't see it, by triangulation, and then just simply scan closer and closer to it. So anyway, one more comment. If you do decide to build this unit, please don't sit around the kitchen table like I did initially and like fire it up with a 200 milliwatt card. It puts out 4 watts, which strictly not illegal, but I don't think you want. That's about 5 times stronger than a cell phone. Probably not a good idea to sit right in front of it while you're firing it up and building it. Like I say, and of course the standard warning for lasers: you shouldn't point them at people or use them in populated areas. We're going to try to do we're going to try to hook it up here and run it. We'll see if the laptops will switch off all right. But I'll tell you what, I'll go ahead and open it up to questions, and then we'll try a little device demo. If we can't get it in here, well, I think we got 10 minutes. We'll be able to fire it up here for you, and we'll be in the next room for questions and continue the demo. So that's about it. Hope you guys enjoyed it, and do you guys have any questions for me at this point? Okay, go ahead. Say again? The compass is plus or minus 1 degree, so it's a really kick butt compass. There's a parts list in the back of my presentation, so if you're interested, I think it's what's called the Nomad, and it's a hiking compass and very accurate. I mean, as far as they go for a manual compass. No, I didn't. I'll be honest with you. I didn't have time to interface it with the computer. I just punched the reading once it locked in. The stepper motor locks that gear, locks the antenna, so it won't move. It was pretty good technique. Absolutely. It's a very good point. What he said was that in amateur radio, this is known as fox hunting. So guys do this all the time and have great fun with it. Not known so much in the Wi-Fi world, but his question was, as you get close to your signal, it gets very strong and makes that bell-shaped peak that we saw earlier get very broad and very strong. It's much harder to get a degree signal position. And actually what I did is turn down the power on the AP. I did cheat a little bit. I turned it down to 30 milliwatts. So we were able to deal with it in that fashion, yeah. I take it you've done it. Yeah. More questions? Yeah. Yeah, I did. I mean, a lot of the amateur guys use the reverse null. In other words, instead of pointing the antenna directly at the target, 180 degrees from the target, works very well because the null basically is the dead signal on the back of the antenna. With a lot of antenna designs, you can really nail them with that. However, I was limited by my 2.9 ounce antenna here. It's all I could get the stepper motor to run, so it actually worked better. I tried the null technique, did not work on this setup. Okay, we're going to try to hook it up here and see if we can get it to spin. What we're going to do is we've planted, one of the goons has planted the access point in here. We'll see how it works. Lovely. Not a problem. We've got some interesting stuff here. All right, so here's the basic technique. You fire it up and get the access point of interest on the graph here. This is the beauty of using the Netstumbler versus the Windows machine interface. If you're a good programmer, you can actually get these signals directly from the WMI. But I chose to just use the front end because it gave me pretty graphs. Hang on. We'll fire up the program here and we'll start doing the scan. It's around. All right. So I don't know what it'll do in this room here. We'll see what it picks up, but it's just going to go around real fast, and we'll see where it thinks the signal is. Any other questions while we wait? No, it's turned down. Reeves says he's got some headache, some pings in his head. So anyway, like I said, not the fastest thing in the world, but it actually pins down the signal pretty well. And here it looks like it's almost equal everywhere. So unfortunately, you can't geolocate in the room too well, it doesn't look like. But works very well outdoors. Actually, I didn't look heavily at the signal. Well, actually, I did. Yeah. There's definitely a correlation. There's a high signal noise ratio with other objects in the path. Obviously. Was that your question? Okay. All right. So it looks like it's finished the scan here, but it should be asking me to go back to the. Okay, so it picked up the max signal strength here. Now it should like go back to where it thinks the access point is. We'll see what it picked. I have no idea what it will pick because it's pretty not a real clear peak on that graph. All right, well, that's where it says it is, back there near the AV thing. I don't know. Is the goon here that hit it? Is the guy here that hit the access point? Do we know where it's at? Okay. We think it's back that way. If any of you guys see my access point, I would like it back, please. It's a link sys about this big. Anyway, thank y'all for coming. If you got any questions, I'll be in the room next door.